Hello, Dr. James. We'll be starting in 30 minutes. We're just waiting for a couple of people to join, and then
That's fine. And thank you so much for your interest in my work. I really appreciate that. That's very kind of you. Thank you.
It's very kind of you to accept our offer as well.
So just tell me a little bit about your group. I want to make sure that I present it at an appropriate level. Obviously, you're interested in bioscience, biotechnology, and some of the ethical issues that arise from neuroscience and its uses, correct?
Right. It's basically, I'll give this introduction during the, when we start as well. It's basically a student-led club that is interested in STEM education. And this not only interests the neurological side, but also many other STEM subjects, etc.
Wonderful, wonderful. That's great. So, I mean, I don't know if you wanted more of sort of an interactive interview, if you wanted me to make a presentation, I can do whatever you want. I mean, it's up to you. Whatever you feel is going to be most useful for your group, for your team, I'm happy to do.
If you have a presentation prepared, we could start with the presentation, and then we could have a small Q&A session in the end.
That's perfect.
Where we could just answer the questions.
Sure, that's great. Happy to do that.
Thank you.
Yeah.
All right. I think we can get started. So I'll start with a simple introduction about me and the Medgeía Club, and then we'll start the webinar itself. I'm Chair Emeritus. I'm a second-year university student, and I'm also a mentor in Medgeía Club. And to provide a brief introduction about the Medgeía Club itself, it's a student-led club focusing on STEM education with the contributions of mentors and some industry experts as well, along with the students that come from diverse backgrounds. And we all sit and discuss and hunt for solutions to problems in the healthcare industry. I would like to welcome everyone to the Neuroethics webinar hosted by Medgeía Club today. Before we begin, I would also like to encourage the viewers to feel free to ask their questions in the chat during the webinar's Q&A session and to be involved in this educational platform for its purpose. The webinar will also be recorded for those who are not able to join today.
Recording in progress.
Today's speaker is Dr. James. He's a professor of neurology and biochemistry, chef of Neuroethics Studies, and co-director of the program in brain sciences and global law and policy at Georgetown University in Washington. His ongoing research addresses the neurobiological basis of neuropsychiatric spectrum disorders and neuroethical issues arising in and from the development, use, and misuse of neuroscientific techniques and neurotechnologies in medicine, public life, global health, and military applications as well. Apart from all of these accomplishments, he is also an elected member of the European Academy of Science and Arts and a fellow of the Royal Society of Medicine UK. He has kindly consented to spend time with us today, and this webinar will primarily focus on his work and research on different aspects of neuroethics, which may be new to all of us. Good morning, Dr. James. It's our pleasure to host a webinar with you, and thank you so much for joining us today. I'm sure your wonderful input will benefit all of us in here.
Well, I certainly hope so. Thank you very, very much, Ms. Medgeía, and thank you all of you from the Medgeía Club to invite me. It's I'm really pleased and actually very honored. It's a privilege to be here, that you're interested in my work. And I was also very impressed with what you've developed with regard to neurotechnologies and some of your ethical, legal, and social perspectives, inquiries, and I think some of the directions that you'd like the field to go. So what I'd like to do over the next hour or so is just present what I view as a sort of deep dive into the field in terms of its most contemporary developments and what those developments obtain and entail as regards key neuroethical, legal, and social issues, and what that would also demand on the contemporary global stage as regards to a neuroethical posturing approach and preparedness. And so at that point, what we'll do is we'll open up the floor for some questions and answers. And if at any time during the presentation I say something or slip into jargon that you don't understand, just shoot up a chat or just come live and, pop onto your mic and just say, could you just clarify that? And I'll be happy to do it, because I want to make sure that this is stuff that, number one, is informative to you and interesting, but also that it's at an understandable level and at a level that you can then use in your discourses here forward. And please understand also, the way I view this is, don't treat this as a one-off. I mean, my thought is, if I can help you in any way and help you to develop professionally in your career and certainly in your programs and provide some mentorship for what it is you're doing, I'd be very proud to do that. And I really admire your work as well. So with that, let's dig into the material a bit. So what I really want to call for here is the idea of neuroethical relativism and realism. So if we look at the brain sciences, I mean, you're doing a lot of STEM work. So realistically, any interaction of the sciences, technologies, engineering, and maths are all involving this very, very similar type of heuristic tango, if you will. We have certain tools that are at our disposal. I mean, initially, those tools are observational tools of our sensorium. And through that, we develop some understanding. We develop heuristics of how the world works and what things mean. And more, that's become mechanistic rather than simply observational. But then what ends up happening is we get to the limits or the boundaries of those theories. And this then prompts us to develop new tools. And so we see this ongoing interaction, if you will, truly a dance of tools to theory and theory to tools, where there's some swap off in terms of who's leading the dance, but they both seem to be very much cooperative in that regard. And the neurosciences have been absolutely no different at all. In fact, in many ways, what we're seeing is the actual field called neuroscience, which has been a titular field, a named field for only 40 years, has really embraced that dynamic of utilizing tools to develop theories, and those theories to then prompt the development of new tools, and has done so in a very consilient or integratively scientific way to be able to pull in not only natural and life sciences, but the physical sciences, the social sciences, and in many ways, the humanities, twofold. First, that some of the perdurable questions of our philosophies, I mean, since we recorded human history in terms of the nature of the self, mind, consciousness, what does it mean to be an embodied person? What is the nature of our emotionality, and even existential questions as to what happens to us when we die? When do we become a person? What does personhood mean? These have been the gauntlet questions, if you will, the questions that have thrown down the gauntlet of both challenge and opportunity for the brain sciences. So we see the brain sciences approaching these perdurable philosophical and humanistic questions. But in using the tool of the brain sciences, in using the capabilities of the brain sciences, we have to then apply our humanistic approaches. I mean, let's face it, the brain sciences, like any STEM, are a human endeavor that are employed for human endeavor. I mean, even those things that we direct towards our ecologies or towards animals, we're directing them. We're defining and deciding what interests are, what's relevant, what's important. And so in recognizing that this is something that exists in the anthropological domain, that it's a human enterprise, we have to ask ourselves, towards what ends? Maximizing survivability? Well, perhaps. I mean, certainly if we take a look at the lowest hanging fruit in medicine, we would say that the goals of brain science are directed towards developing assessments, viability of interventions, cures, preventions for a variety of diseases, injuries, or just the human predicament of relative decrepitude as we age, or things that are congenital. But it's not just survival, clearly. I mean, an extended human lifespan also dictates that we seek certain levels of flourishing. And indeed, the essence of utilizing tools iteratively through our history has not just been so we can survive, but we can survive well, better, flourishing. And of course, this then gets in the interesting dynamic of what constitutes treatment and what constitutes optimization and or enhancement. And a particularly fuzzy zone, literally a fuzzy or gray zone, is the area of preventive medicine. We're actually working with healthy individuals and preventing what? Preventing some slip down a slope, whether that's slippery or not, into what? Cognitive decline, physical decline. And if we're preventing that slip, are we actually enabling or empowering or maximizing individuals' functionality across a range of possible capabilities? So I think what we see is that what the brain sciences have done is really allow this integrative approach to assess the brain, access the brain, and affect the brain, the three A's, if you will. Now, again, the most proximate goal of that being biomedical is to define and to approach, to assess, and to treat what might be pathologies. As we define the pathologies, what is norm, what is abnorm, function, dysfunction, and here too is a relatively gray zone and a zone of some provocativity or contentiousness, because we're using the tools of neuroscience to define normality. And this has to appreciate, I think, the larger biopsychosocial framework of the reality of human culture, difference, diversity, as well as equalities. But over and above that, I mean, if what we're doing is we're treating pathology, we also have the capability to alter our sensorium, our thoughts, our emotions, and our behaviors. And what I like about the slide that you see here is that it really provides something of a 100-year history of the brain sciences. Only in the past 40 years has this field neuroscience been called neuroscience. But that in many ways belies the fact that there has been a longstanding interest in what makes us tick, what provides, if you will, the great stuff of consciousness, mind, self, emotionality, creativity, joy, from the gray stuff of those cells in our head. I mean, one could actually speculate a bit more philosophically and say that even early on, when these proto-humans may have looked into some reflecting pool and recognized that this thing looking back at them as themselves, the question was, all right, how do I know that's me? And if I'm knowing that's me, then obviously I'm thinking, so what's going on? And this brings us right up to the work of the mathematician and philosopher René Descartes, cogito ergo sum, I think, therefore I am. But the challenge for the brain sciences was twofold. Number one, well, how do you think? And then how do you modify such thought? What can we do once we understand how it works? This is really what brings us into the domain of neuroscience and its technologies that are somewhat colloquially referred to as neuro S&T. And we can parse neuroscientific and technological developments, activities, instruments, and approaches into three major categories, and they're not mutually exclusive. We have the assessment neuroscientific and technological approaches, and these include things like the use of peripheral and central biomarkers, genetics and genomics, proteomics, various forms of imaging that more and more are being used in a co-registered and convergent way that ultimately lead to forms of brain mapping, brain modeling, and then the idea of being able to assess the brain on a variety of levels from the subcellular all the way to its potential social engagement. But again, understand that the ability to assess something is fundamental to the way humans use tools. And humans are prototypic tool users, as are other species. But we've used tools to our advantage to essentially come to the top of, if you will, the phylogenetic ladder. And in so doing, using tools to be relative engineers of our own evolution and our own ecologies. What we use tools for assessment to do is to develop insight and perhaps engagement of a variety of manipulable targets. So we don't just use tools to look, see. We use the ability to look, see to then have the possibility to engage, to modulate, to modify, to manipulate, and to intervene. And we like the word interventional because it's a bit more benign than manipulative, but let's face it, what we're actually doing is we're modulating and in that way manipulating brain structures and functions. And those brain functions cumulatively are the thing we refer to as mind, cognition, emotion, behavior. And those cognitions and those emotions are both retrospective with regard to our personal and community history, as well as present and predictive. So the ability to intervene on those levels spans, if you will, human time capabilities and human spatial capabilities on a variety of scales and levels. And we can do that right now. I mean, nothing that I'll be talking to you about today is science fictional. It's all science factual. But the factuality is in some ways stranger and perhaps more contentious than fiction ever could be, because it literally puts the brain at our fingertips and puts our fingertips into brains on a variety of levels, from the individual all the way to the international. The interventional techniques include an understanding of the brain that has allowed far more specificity and precision in the development, articulation, administration of drugs. For example, the merging of technological engineering and drugs to create things like nanoscaffolds and nanomicelles that are able to deliver drugs more capably across and through the blood-brain and blood cerebrospinal fluid barriers, to be able to have more of a sharp shot versus buckshot effect, has been a real boon. As well, delivering drugs through very specific means whereby cannula and micropumps are implanted in various areas of the peripheral central nervous system affords much greater site specificity and therefore increases the viability of both pharmacokinetics and pharmacodynamics. We also have a variety of means of peripheral stimulation that can engage the peripheral nervous system, both parasympathetically and sympathetically, and maintain some balance there. Neurofeedback that is linked to EEG or other forms of neuroimaging. Transcranial modulation that employs electrical stimuli as well as magnetic stimuli, and these are donnable and doffable, and ever more are moving into the purview of direct-to-consumer environments and even do-it-yourself environments. And then we can be far more specific and gain granularity and precision in that specificity through the use of implantable devices, which currently are primarily administered via neurosurgical approaches. But as you may be aware, there are a number of programs, probably most notable, the contemporary program of the Defense Advanced Research Project Agency, DARPA, called N-Cubed, which is the next generation non-invasive neuromodulation program that seeks to develop the means, the technologies, and the methods to utilize non-surgically implantable devices that can both sense as well as transmit into the living brain remotely, utilizing a vast array of nanoscalar or high nanoscalar electrodes that are then capable of being directed within the brain by a variety of means to literally create a viable network unto itself to interact with the brain's networks, to read from the living brain and to write into the living brain remotely in real time. Obviously, we can also utilize our technologies to develop various forms of prosthetics. The idea of hardwiring feelable haptic prosthetics has become a reality within the past 10 years. And those prosthetics are not limited to peripheral neuroprosthetics, but ever more central neuroprosthetics. For example, the Restoring Active Memory program of DARPA and some of the programs of the European Union's Human Brain Project, as well as other international brain projects, seek to integrate a variety of hardwares, as well as hardwares and softwares that are directly implantable and in that way usable and valuable as indwelling central neuroprostheses to be able to, quote, repair a broken brain and extend brain function across a range of possibilities. And each and all of these approaches on the assessment side, as well as on the interventional side, have been capabilized by the use of big data and at least some form of decisional technology, and we might consider to be advanced learning procedures and decisional procedures that we might group under the heading generally of forms of artificial intelligence. And then, of course, we need to be concerned as well about what we do with these neurodata. As you may be aware, my research group, working with a number of colleagues, both nationally and internationally, is very concerned about the relative ubiquity of data that are being gained from the assessment neurotechnologies and neuromethods, and what these things can, should, or might be used for, and how they're used. The idea originally proposed, for example, by Stephanie Kostyuk almost a decade ago, that we might need a very, very specific Neurological Information Non-Discrimination Act, a NINA, I think bears particular fruit nowadays, given the increasing capabilities of big data and AI, to be able to realize many of the heretofore impossible capabilities of being able to assess the brain on a variety of levels. Well, I mean, if we take a look at each one of these, assessment technologies and the affecting technologies, they all give rise to a number of ethical, legal, and social issues. And I think confronting and addressing those directly becomes very important. One of the more contentious, as you may know, have been advances in neuroimaging. And although there had been prior consideration and I think criticism that neuroimaging was almost as a form of contemporary, if you will, phrenology. I mean, to use the words of Dr. Robert Udall. I mean, that wasn't necessarily dismissive, and certainly in no way was it dispositive. I mean, the people who did phrenology really thought they were onto something. The question is, were they onto something, or were they leading themselves on in a performative way? And that was the criticism thrown at much of neuroimaging. In other words, we're defining the thresholds of what's important and what isn't, what's signal and what's noise, and then we're using those in both a comparative and a normative way. But one of the things that we found is that we can delimit some of the restrictions and constraints of various forms of neuroimaging by using them together. For example, utilizing certain forms of structural MR and CT together with molecular functional MR, real-time functional magnetic resonance imaging, and various types of tractography, when coupled with tessellated forms of magnetoencephalography or quantitative encephalography, provide a very, very good cross-factorial registration of the brain in relatively real time to be able to assess what's happening with regard to structural functional relationships and assemble that into a repository of pattern correlations. Well, what are we really doing here? I'll tell you what we're doing. We're scanning the brain and literally, I mean literally, per the Oxford English definition of what reading means, we're reading the brain and reading what it does. So from the scan of the brain that we read, that we interpret, we're reading into that, reading from that, our construct of what its functions are. We're reading the mind, literally reading the mind. We're taking a set of images, we're taking a set of symbols that we've constructed and that we've construed, and we're assembling them into a meaning order that then provides for us input on a variety of levels that then develop a concept and a construct that is realizable for us. Just as you may be reading these words on the page right now, you have to know what an N is, and you must know what a E is and a U. Not only what it is, but you have to know how it sounds. And then putting that together, you have to recognize that N-E-U-R-O is pronounced neuro in English. And what that means. Neuro refers to things of the nervous system. You have to know what a nervous system is, and by implication, the brain. And we're seeing all these levels of communicated meaning. In this way, it's a word game, a language game, to sort of paraphrase Ludwig Wittgenstein. But what we're really doing is we're going beyond that. We're also playing some form of picture thinking. We're seeing images and we're interpreting the images. And very often it's those meanings and or interpretations, misinterpretations and miscommunications that can give rise to some of the gaps in information and or the misinformations that create ethical, legal, and social issues. So throwing down the gauntlet of opportunity, can we use forms of neuroimaging to have a better idea of structural functional relations in the brain, number one? Can we use those things, for example, to devise and or direct certain surgical or non-surgical interventions? Can we also use this information to understand how brains are similar and how brains vary across populations, if not internationally? But then in using those similarities and distinctions for individual and group comparators, what can we use the information for? To define normality? To define normality and diversity across some Gaussian or quasi-Gaussian distribution, and then impart upon that means for social regard, social treatment, across a variety of different social implications and institutions, from medicine all the way to law. And can we use these types of images in ways that are legally viable, that uphold codes of federal regulation on national levels or international scales? Can we use this to assess subjective states and thereby provide some objective measure of the interiority of those subjective states? If we say that one's consciousness, one's state of mind, one's feeling is purely subjective and transparent only to myself unless I communicate it, is this a means to then create some objective measure for the interiority of the subjective phenomenological self? And what will we do with that? Similarly, we could ask these types of questions also about neurogenetics and neurogenomics, growing greatly out of the Human Genome Program. Clearly, we identify that there are genes that are contributory, if not responsible, for structures and functions within the nervous system. And as you may be aware, just a couple of weeks ago, we finally decided that we have indeed defined the entirety of the human genome. inclusive of those genes that may be participatory in neuropsychiatric and neurocognitive states, conditions, and abnormalities. If we can identify these genes and identify their relative roles, divergence, convergence, pleiotropic effects, with some specificity, or at very, very least, with some reliable correlation, what we may be able to do is have a predictive index of how genes affect phenotype in a variety of different environments. Well, that's not only predictive. Remember that we use our assessments to access and affect those things that we've assessed. And if you will, the relative ubiquity of what appears to be these novel techniques of genetic manipulation, the one we're probably most familiar with these days is CRISPR-Cas9 and related Cas type systems, but taken not in isolation, but together with other forms of techniques and technologies of synthetic biology, then allows us not only the capability to be predictive about what genetics and genomes may mean for the expression of phenotypes, of structure and function, but to intervene at the genetic level, to be able to modify structures, ergo possible functions, across a range of timeframes from the prenatal all the way through the lifespan. And the question there is, realistically, can we then use these things in a reliable way? Will we have the prudence to understand what is reliable, responsible, and therefore valid in ways that are descriptive, predictive, or in some cases, interventional to create and modify what is the nature of the self? And as we're moving more into the interventional domains, then clearly what we're seeing is an increased reliance upon brain-machine interfacing. Well, without doubt, I mean, I think the longstanding mantra, at least for the past 200 years, has been better living through chemistry. The rise of chemistry from alchemy and ultimately the rise of the pharmaceutical industry from biochemistry and physical chemistry enabled the late 1800s and 1900s to essentially be the centuries of the drug, whereby we were developing ever more capable drugs as a consequence of both our understanding of physiology and our understanding of the chemistry, and the capabilities that we had to induce various chemical changes on a variety of durable levels and utilize them in both the clinic and in public life. But drugs can be messy. And what I mean by that is that even a relatively specific drug that is working through a particular set of receptors or membrane domains or some perhaps internuclear domain are going to work in a variety of different places in wherever the system has it. In other words, whether you're giving these things to the brain, they may have bodily effects and vice versa, or they may be sort of heterogeneously dispersed throughout a brain. So very often what we're concerned about are side effect profiles of drugs that reflect not only the drug itself, but where the drug is interacting with the substrate that the drug is working on. Well, one way we can sidestep that, certainly, is through the use of indwelling devices to the brain that will deliver very, very low doses of drug. I mean, one of the things we're interested in on our side, in our research group, working with my colleague, Dr. Edward Calabrese and Vittorio Calabrese in Italy, and Ed Calabrese here up in Massachusetts, is the very, very, very low dose, the nanoscalar dosing of drugs delivered directly onto the target tissue via the use of cannula, micropumps, or other forms of indwelling or deliverable devices that might even approach Avogadro's number in terms of their density and concentration, but then have a high amplification effect. It's called a hormetic effect in the target tissue. Sharp shot, not buckshot. But here too, we have to worry about getting the micro pump or the micro cannula or the micro delivery or nano delivery device into the tissue. And so once again, we're relying on technology and engineering. And in so doing, we have other technologies that might sidestep the use of drugs or may in some way synergize, augment, improve, force multiply the use of drugs to allow lower doses with higher specificity and lower side effects. These technologies are growing. For example, we have transcranial stimulation utilizing transcranial electrical stimulation and transcranial magnetic stimulation. Transcranial magnetic stimulation is a bit more understood in terms of its actual mechanisms, but transcranial electrical stimulation is, in fact, generating a fairly large body of literature to suggest that whether working through the cranial nerves or directly to affect the brain in situ, these are very easily applied forms that are donnable and doffable, that we take on and off, and that may also be viable for direct-to-consumer use and direct-to-consumer provision. But more than that, these types of transcranial approaches have also been the focus of a growing international do-it-yourself community, a neurobiohacker community, and which, while not problematic per se, can in fact be seen as a possible locus for purloinment, whereby infiltration to that community might then lead to problems with what's being developed and how it's used, and or the fact that at times, although the community on the whole practices sound, responsible conduct of research, failure to engage institutional review boards and or failure to have any constraints upon how the products and outcomes of do-it-yourself biology and neuroscience are used could be problematic on a number of levels. I mean, from the public health level all the way to the political. We're also dealing with xenografts and tissue grafts, and although there had been ongoing debate primarily over religious concerns about stem cells, many of those have been mitigated. And the reason being is we can now use non-fetal and non-embryonic stem cells, the body's own cells that can then be reprogrammed to then be developing into multipotent or pluripotent or monopotent directions as replaceable stems. These stem cells can be placed into the brain where they can differentiate. And although what we understand is there still are some constraints. In other words, are you just getting multiplication without differentiation? Might these things develop into neoplasm, in other words, cancers? What is the interaction between the brain environment and the cells? Who's controlling who, so to speak? If I put new cells in that are healthy into a diseased brain, will the diseased brain affect the cells, or will the cells affect the diseased brain? So again, we're at the forefront, if you will. We're standing in the atrium of the possibility of taking these probabilistic capabilities we have at hand and expanding them into a higher level of validity and therefore value. But the question that arises from this is, how far do we go? I mean, without doubt, I mean, the goal here is to, number one, do good, avoid harm. But what goods? Who defines those goods? How much good? What harms? What's harmful? Pain? Yeah, without a doubt, but is it always harmful? And how much pain? Sadness? Frustration? What about those things that are both individually and socially threatening, if not disruptive? Aggression? Violence? Can we use these techniques to be able to assess predispositions and or escalations to these points of aggressive departure and violence, vulnerabilities? Can we also use these techniques and technologies as, quote, neurocorrectives, whereby individuals who previously may have been incarcerated now, hopefully with consent, then receive these forms of techniques and technologies so as to modify their brain structures and functions, and in this way change their thoughts, emotions, and behaviors to make them less vulnerable, volatile, criminal. And this way allow them to reintegrate to society to perform some useful role, not in a way that in any way exculpates them, that alleviates their guilt. They're still guilty of whatever it is they did. But now, rather than the burden being borne upon society to keep them incarcerated, which obviously is a nature of debate as to whether or not there's rehabilitation in incarceration, not depending on the system, these individuals can now go back into a service role within the society in a way that can be trusted. Or can they? Are these devices purloinable? Are they hackable? Are they modifiable? And who decides who gets these devices? In open societies and liberal democracies, we place great emphasis upon autonomy, at least as the negative right of refusal and informed consent, but those precepts are not universal. And what does that then mean? And then we keep going. I mean, realistically, one of the things we're seeing is the iterative integration of machine systems and technologies within the body, whether that body is a human body or an animal body, engages the process of these feed-forward and feedback systems on a variety of scales, from the subcellular all the way to the systemic, and affecting the individual all the way to the interpersonal, intersocial. This is the true cyborg, the cybernetic organism, which is not a thing per se, but is actually a level of iterative progress and engagement of techniques and technologies within the biological system. Level 1, simple use of machines. Level 2, donnable and doffable technologies. Number 3, indwelling non-removable technologies. Number 4, reproducible technological effects that are then propagated generationally. And number 5, the creation of organisms anew that are a fusion of technology and biology. We've achieved each and all of these levels to date. Towards what end? Augmenting cognition, emotions, behaviors, augmenting communication between humans and machines, between humans and other species, developing machines that are reciprocal learners, the idea of artificial intelligence, might also imply that any such intelligence might then become sentient, conscious. And what do we do about that? We've only now begun to really appreciate that what the neurocognitive sciences has taught us about organic creatures, animals across a variety of phyla, are capable of the mental processes that we entertain to be some form of consciousness. What does that mean for the way we morally regard and socially treat those creatures? What will that mean if, in fact, or perhaps more realistically, when, in fact, we develop a machine system that is not only capable of making cognitive decisions, but is aware of time, aware of place, aware of itself? Does it have a self? And if it has such a self, how do we regard it? What might we make? What might we become? And as you all may know, and in full transparency, for a number of decades, I've been working at the interface between brain science and multiple national initiatives of defense, intelligence, and security, which might be more colloquially referred to as examining the ways that brain sciences can be used in military and intelligence operations. In other words, the weaponization of brain science. It's not new. The weaponization of any science and technology has been virtually as old as human history. We can look back to the ancients, through antiquity, to the modern period. And what we see is that realistically, almost every culture seeks to incorporate the latest and greatest developments from whatever they regard to be science and technology, tools and methods, knowledge and know-how, to be able to defend what they feel is right and good, defend kin and kith. In open societies, the idea there is that politics is defending the polis, but not all societies are open. More and more, what we're seeing is that the range of societies on the global stage that are engaging neuroscience also increases the possibility, if not reality, that said neuroscience and technology are being uptaken and utilized in their programs of national security and defense, whatever those programs obtain and entail. Are we ready for this? Are we prepared for the brain as the 21st century battle space? I don't have answers for you. I don't. I mean, these are the questions that you, as future professionals entering the field, not only can deal with, but should deal with. I mean, as you have through the discourse that you've been entertaining thus far and the documentation towards developing and informing good policy and guidelines. And I commend you on that. But what I can tell you, I mean, I can tell you with surety, is that the brain sciences and its technologies can and will change the human predicament of the way we approach pain, suffering, loneliness, relative decrepitude, congenital impairments or congenital conditions, and perhaps even the span and quality of our lifespan. It'll certainly change human relationships with science and technology, human relationships with machines, relationships with each other, relationships with other species in ways that can be unpredictably either positive or negatively valent. It can change the human condition. And in many ways, it can change what we define to be human. How much technology can we bear within ourselves in an inextricable way as we continue to take ourselves towards the journey of transition, literally the human in transition, the transhuman? And will we appreciate, appropriate, and perhaps even address, if not try to acquire, what the scientist and philosopher Donna Haraway has termed the post-human? In other words, perhaps in a benevolent way, moving beyond some of our human biases, dispositions, constraints, prejudices, moving beyond the relative constraints of standpoint of biology to create a more encompassing human. A human that has, for example, a diversity of traits that allows us to assume multiple standpoints, male, female, various ethnicities, races, etc., structures. Or will we make something that comes from us that develops some form of intelligence that is just as capable, if not more capable? Is artificial intelligence and the development of neurally capable networks that don't use neurons, but instead use systems of both our design and their design, the post-human? Will neuroethics be capable of dealing with that? And to what ends? Survival is not just the option any longer. The option here is flourishing, doing better, improving quality of life, quantity of life, and capabilities of life. And this is really where we need to appreciate the idea that this is the human trajectory in transition, the true transhuman. Cyborgization, Homo technicus. But what I throw out to you, and obviously what you're wrestling with by virtue of the document that you allowed me to view, is not just Homo technicus, in other words, the tool using human, but the human that appreciates in a rational way what the development of those tools are, the purposes, the motivation, the potential uses, and who's using those tools. Homo technologicus, techne, the art of using tools. Logos, a rational accounting of the thing itself and those who develop and use it. Homo technologicus. It's technology redux. I mean, realistically, I think we need to go back to the future and reappreciate what the word technology means, particularly as it relates to neurotechnology. And the reason for that is simple, because this rational accounting not only uses a lens to look at the brain and/or a lens to look at neuroscience and its tools and methods, but turns that lens around as a mirror to look upon ourselves. Are we ready? Do we have the information, the policies, the guidelines in place? Are we prepared for the level of international discourse and dialectic that's going to be required to be able to adjudicate, decide, come to consensus about various areas of alignment and dissensus about what to develop, how to develop it, how to use it, who gets it? And the reasons for this is critical, literally critical. Vis-a-vis, there's a reason of criticism, in that indeed what has happened is that brain science is a multinational global event. It's not just the Provence any longer of what used to be called, in quotes, the West. Clearly not. Oh yes, there are large-scale brain initiatives in the United States, one called the Brain Initiative, Brain Research to Advancing Innovative Neurotechnologies. There's a profound multinational initiative in Europe that's called the European Union Human Brain Project, but not just. A number of countries, Japan, China, India, Brazil, Argentina, Australia, New Zealand, each and all have national brain initiatives and/or agendas to which billions of dollars of their national currencies are being poured, which then advances the scope and pace. But wait, these nations have different cultures. Cultures have different histories. Histories give rise to different needs and values, and those values are part of philosophies that ultimately dictate ethics. The ethics are not uniform. It may be problematic to say that we, whoever we are, have the ethical system that must be used. Realistically, if in fact neuroscience is about affecting the human condition, then nothing about us without us. But who is that us? That us is the global community. And more what we're seeing is that the neuroscientific and neurotechnological, if you will, pathways forward isn't just a road forward. How do we take the path forward? That global path forward is multi-laned and it's super fast. We like to hearken it or relate it to an international Formula One super speedway. Multiple lanes, many countries, multiple entries, different types of technologies and techniques, a very rapid pace. Now what we see is the pace of development from neuroscientific and technological concept to a workable construct of method or tool occurs in less than 5 years. Highly competitive in terms of great achievement, notoriety, also economically competitive given the scope of the global neuroscientific and technological market. And that market also renders certain hegemonies, capabilities of power, what the French philosopher Michel Foucault referred to as biopower. And when yielded on a national scale, biopolitics. And the prizes are those hegemonies and capabilities. But just like an international superspeedway, it's not without risk. The pace, the technological drive of the entries, the competitiveness, all add particular risk to the apparent benefit of the prizes at hand. Well, what are these ethical, legal, and social issues and risks? I mean, in the main, as you've defined at least in part, they can sort of parse these into two major domains, those that are directly focused and emanate from the technology. Let's face it, I'll be very honest with you. I've been doing brain science for 40 years, literally 40 years this year. And the hard question of neuroscience, of how the great stuff of consciousness, mind, self, ideas, phenomenological self-identity and subjective reality comes from the gray stuff of cells packed in your head, we don't know. This is what the philosopher and cognitive scientist David Chalmers has referred to as the hard question or the hard problem. Oh yeah, we're developing the tools to assess these things, and perhaps we won't know unless we go and build these tools. But now what we're doing is we're confronting the intersection of unknowns. We don't know how the brain works per se, at least on the level of efficient causality. And we're building tools to assess that, but we don't necessarily know what the tools are going to do to the brain and to the bodies and organisms and societies that are embrained and embodied. What are the real capabilities and what real limitations? What is the validity of these findings, their viability of use, and therefore their relative value? And if that value is strong, will the technologies run away from us, either in terms of the technology itself and that it some way changes our biology and our nature in ways that were unpredictable, or will the demand sort of pull that technology forward into domains and dimensions of use that were not intentional? And this brings us squarely into the social milieu. Socially, is there something inviolable about going where we haven't gone before and trying to understand the mind, reading the mind? What the cognitive scientist and attorney Nita Farahani has referred to as cognitive liberty? And what about mind control? If in fact we're using these techniques and technology to be able to modulate neural systems and their structures and functions so as to modify thoughts, emotions, and behaviors, well, let's not be semantically polite. This is mind control. Who's going to do this? Under what circumstances? What are the conditions for consent? How aware can we really be of what the benefits, burdens, and risks may be? And if in fact, one of the things we're saying is we're looking to avoid risks, we're looking to increase the benefits and decrease the burdens of life, well, then what are we using these things for? Treatments after someone gets whatever it is we define as a sickness, a disease, after someone is injured, or beforehand? Are we really using these to leverage what our research group has referred to as hope, health, occupational protection, and enablement that are not mutually exclusive? I can enable people to do certain things that makes them more resilient, more resistant, and that way more protected in their various occupations, professionally and avocationally, and keep them healthy. What definition of health? Who gets the goodies? How do we decide? And what are those goodies used to do? What goods? And will we use the science and technology to defend those things we hold as good, and this way uptake them into initiatives of national defense and security, to defend those things that we view as good for our kin and our kith, and that what we look to ensure and defend against any potential harms? And as I said, more and more what we're seeing is this is an event on the world stage. Thus, any real approach to looking at these risks and or ethical issues must appreciate the internationality of this, the non-Western nature of this, and must accommodate pluralist needs, values, norms that are affected by economics and that affect economics, politics, and power balances. Well, if this is a speedway, our group, some 5 or so years ago, tasked by the American Medical Association and by others, developed a risk approach. How do we assess and decrease both idiosyncratic and systemic risk? And going with the metaphor of this being a speedway, we proposed something that we called rather cutely on-ramp, operational neuroethical risk assessment mitigation paradigms. And it begins with 6 R's, moves to 6 W's, and then frames within 6 C's. So 6, 6, and 6. Some of my colleagues have said, oh my God, that's almost demonic in its approach, but we've added another 6 just to make sure that we've gone from the demonic to the deified. The 6 R's is a responsibility for realistic assessment of the technology, research, responsiveness to not only the benefits, but the burdens and harms, revisions in the technology and the way we market, talk about, discuss. That must be realistic, and ultimately regulation, as you're trying to do by informed policy and guidelines. To do this, we pose what we call 6 questions, 6 W questions. What neuroscience and technologies are available for use? Why is a neuroscience and technology being considered or advocated for use in these particular situations, contexts, and circumstances? Who's going to receive it? When? In a treatment algorithm, in a preventive algorithm. Where? Hospital, clinic, physician's office, home, school, work? Which mechanisms will be in place for ongoing provision of services and resources necessary to assess, maintain, and sometimes correct those things that are part of the neuroscientific and neurotechnological intervention? And all of these things, these responsibilities and these questions must be framed within what we call considerations. What are the actual considerations of the capacities and limitations of the neuroscience and technology? Not something you make up, not something performative. What can they really do and what can they really not do? And what do those capabilities and limitations confer? What do we do with the capability and knowledge we have? What are we doing about the capability and knowledge we lack? What are the consequences of using a particular neuroscience and technology or not using a neuroscience and technology on recipients and persons, on their families, on society at large? What is the character of the research and what is the character of the use? And how does the character, the intent, the motivation, the directionality of such uses in practice affect the character of the individuals who are being assessed or affected? What are the contexts? Ethics is all about the effort. The contexts differ. Medical contexts are one thing. Lifestyle, wellness, and self-improvement represent something perhaps different. Uses in the military and security may be different. Uses in the law may be different still. How do those contexts assemble and create particular risks, burdens, and benefits that must be appreciated in any realistic consideration of what a neuroscientific or neurotechnological approach may yield or may not? And this is new stuff. It's brand new. We haven't been doing this for decades. Realistically, even if we look at the 4 decades of the titular neurosciences, some of these developments have only occurred within the past 5 to 10 years. And a snowballing pace is such that these things are developing rapidly. Are we going to be responsible for what we make and what we do? Are there provisions? Are there the resources, services, funds for continuity of research and continuity of clinical care? Not if things go wrong, when things go wrong, because they will go wrong. I'll tell you why they will go wrong. Because the more you let the cat out of the bag, the more potential harm the cat's going to do. That's not saying the cats aren't cute or fuzzy or cuddly. That's the reason we take the cat out of the bag to begin with. We want to pet it, we want to play with it. But naturally, cats have claws, have teeth. They eat, they pee, they poop, they shed. Are we ready for those consequences? But more than that, the more individuals have access to and who are using these techniques and technologies, the greater the likelihood for variation in the way they're being used, from the very appropriate to the exceedingly misappropriate, from the inadvertently misused to the intentionally abused. And let's face it, given the diversity of human genotypes and phenotypes, although we think we have an idea of how these things will work, that heterogeneity is likely to spawn effects down the line that occur with time that we didn't anticipate, simply because we haven't been dropping these techniques and technologies into people in a diversified genome and or a diversified phenotypic milieu for a period of time. So the more diverse the people who are using these things over time, and the longer they're using them, the more diversified effects we're going to see. And some of them are bound to be problematic. Will we have those resources in place to be able to care for those individuals? I don't know. Towards developing such wisdom in practice, what I advocate and what I perhaps recommend to you is an older principle, a principle that was originally advocated by Aristotle. Practical wisdom. Fancy word for it, sounds great in Greek, it's phronesis. What it really means is that we need to be pragmatic in our perception, our practice is very much the same as being advocated by William James. But we also need to be pragmatic in our perception and articulation of practice. Here, I allude to some of the work of the philosopher Alistair MacIntyre from the University of Notre Dame, in that a practice represents a relationship between those individuals who develop certain things and have certain things and those who need it, and what are the parameters of that relationship. Pragmatic in perception and practice. In developing neuroethics, we've said that we can develop a neuroethics that is based upon practical wisdom. In other words, it shouldn't be performative and make stuff up and deal with pie in the sky, chicken little, or cry wolf scenarios. What can we really do? What can we not really do? What are the ways that neuroscience and technologies are really being developed? By whom? For what uses? It needs to be principled. It needs to be integrative across not only the sciences, but the social sciences and humanities as well, and integrative across cultures, and in that way contribute to the real world. Realistic. It needs to be globally relevant. Why? Because I just told you why that's so important. Because neuroscience is not a unitary enterprise performed by just a select group. It's global. But even in its globality, there is some selection and inequity and that the neuroscience is primarily being developed and articulated by developed countries. What does that say for the relationships between developed, developing, and non-developed countries in terms of the neurotechnologically enabled haves and the neurotechnologically deprived have-nots? So it needs to appreciate the multiculturality and the accessibility of the multiculturality of the 21st century global stage. Therefore, it needs to have a cosmopolitan palette. In other words, it needs to appreciate literally multiple polis, multiple cultures, multiple philosophies and ethics and what they mean and why they're important to those cultures. It also needs to acknowledge those local values. And when in fact things are being done locally, it should appreciate what those local needs and values are. But where it gets tricky, where it gets truly tricky, is when we then try to entertain this on an international global scale. Because now it's not just a question of the science and technology and who's developed what and who may use what. It's how do different cultures' values, needs, intentions, motivations, and capabilities interplay in a way that very often can involve cultures with differing views, differing histories, differing philosophies and ethics. Do we have a methodology, literally a rational accounting of our methods, to be able to go to that discourse table dialectically? I don't know. I mean, I think that this is the thing that you're struggling with, and that certainly we're working to try to at least establish the parameters for how we might move forward and how we can move from what is to what ought to be. What neurosciences and neuroethics, what are they? They provide tools. What we make of this, what we do with this, well, that is our responsibility, our opportunity, and our challenge. What it is great capability. What it is cutting edge science and technology. What it is being able to engineer our own evolution, our own environments. What it ought to be, how do we do it? How do we work together to do that in a way that is increasingly cooperative, even though we recognize there is some competition? Is there room for what is called co-opetition? And what does that mean? Are we ready to be truly dialectic and not only synthetic, but syncretic in bringing our beliefs together in a way that have agreed upon domains of alignment and disalignment? I don't know. It's my hope. I'd like to think that there's a part of me that's optimistic, although the majority of me is highly pragmatic. And the pragmatist in me says we need to work at it. And this is not new. This is not, I'm giving you my wisdom and you go, wow, my head's going to explode. This has been around for a long time. The philosopher and historian of science, Bruno Latour, says that science doesn't bring us any answers. It only prompts continued and ever deepening questions. Correct. The capability that neuroscience and neurotechnology afford answers particular questions, perhaps about the structures and function of the brain, but opens literally a Pandora's box of other questions with regard to what that means for our social interactions and discourses. More than that, Johann Wolfgang von Goethe said that science asks what? Philosophy asks why, but it's our ethics that essentially guide how. I'll tell you how. It becomes very important to assume a realistic stance in our neuroethics. We need to cash the reality check, if you will, and audit our understanding of neuroscience and technology, audit our realistic grasp on what neuroethics is and can be, audit and understand medico-social views and expectations of both neuroscience and neuroethics, and in that way, write that check that realistically informs the capital of regulations and policies. Because what will be, I got to tell you, I mean, I'm going to tell you what will be by my own experience, is that use in practice of these things as they go from bench to bedside to beyond will incur certain, at least unanticipated, if not what could be viewed as deleterious effects. But that doesn't necessarily prohibit or prescribe their development and use. That's the job of ethics. The job of ethics is to model certain things forward, to do so in a realistically predictive way, so as to remain apace with the science and technology. It obligates rigorous monitoring, continued research and development, engagement on the clinical and social interfaces, revisable guidelines and regulations, and ultimately guidance. Because moving forward, we don't want to use our techniques and technologies to untangle the Gordian knot of the brain, only to open a socio-legal and ethical can of worms. How problematic would that be? So I'm going to leave you with a take-home message. And I always like to use these discussions as and the termination of these discussions before we get into a Q&A to relate a little personal story, if I may. It's a story about my dad. My father was an engineer. He was a nautical engineer. He was a submarine designer. And being an engineer, he liked to work with tools and fix things. And in fact, that was one of our father-son activities when I was a kid, is we'd go downstairs to his workshop and we'd work on things, restore things. I still like to do that. I work on motorcycles and engines and planes and restore furniture and stuff. And the reason I do that with such joy as an adult is because my father was a pretty good teacher as well. I mean, he taught me how to use tools. In fact, what he would do is he would introduce a new tool to me every month. He would do it on the first Tuesday of the month. He called this New Tool Tuesday. He started this when I was around 6 years old. I mean, I remember I'd look forward to every Tuesday. I'd get a new tool, and then he and I would spend the month learning about the tool, how to use it. And then, of course, we'd combine that with the other tools. So I remember this one day, I must have been, I was in 5th grade, I remember. So I must have been about 10 years old. So do some simple math. Started this when I was 6, about 10. So I knew how to use about 50 tools. That's a lot of tools. I remember his New Tool Tuesday. My dad comes home, he's got this new tool. He's like, look, I got this new tool for you. I was so excited. We were already working on something down in the workbench. So I grabbed the tool. I was like, thanks, Dad. And I go running off to go downstairs to the workshop. My dad put his hand on my shoulder. He said, hey, slow down. Measure twice. Cut once, because sometimes you really can't take back what you do with your tools. Boom. Great advice, Dad. It's advice that I pass on to you. I think it's the advice that you're using as the yardstick to develop the informative documents that are going to be so important to understanding neuroethics and developing neuropolicy. Let's measure twice. Let's use those R's, those W's, and those C's, and let's try to develop a cosmopolitanly capable and locally responsive neuroethics that appreciates differing cultures, differing values, and differing views, and does so in a way that is synthetic and syncretic. Let's measure twice, not only what the science and tech can do, but what we're capable of doing as people, as a polis, as individuals, as an internationality. Because the future's in your hands. I mean, really, I told you, we put the brain in our fingertips and you're holding on to it. So I would really hope we wouldn't drop it. If you're interested in more information about some of the work my group has been doing over the past decade or so, I provide some of that here. And if you want to read a little bit more about some of the things we're doing, I provide this for you, not because I'm urging you to go out and buy it because I'm going to go buy a new Mercedes-Benz or something. I'm not. I'm proud of it, not because I wrote it, but because I served as the editor for this volume. And I was privileged to be able to bring some of the greatest minds to the fore to provide their views, their voice, their visions of what neurotechnology is, its premises, and its potential and problems. And those visions and views come from science, technology, engineering, medicine, research, philosophy, law, sociology, anthropology, and they're multinational. And so I recommend this to you. And of course, although we have time for some question and answer, as is appropriate, I mean, sometimes these questions might need to percolate, or if in fact you think, well, hey, can you help us a little more in what I view to be a very applaudable and laudable effort, feel free to get in touch with me. You can reach me directly here, james.giordano@georgetown.edu. And with that, I'll stop our presentation and I'll open up the floor for some questions and answers. Over to you. Questions?
I cannot see any questions in the platform now. Maybe like they're typing out the questions right now.
Nope, I don't see any questions. So that either means they really enjoyed it or they really hated it.
I think everyone enjoyed it.
I'll take that.
There's a question in the chat. Can you explain the involvement of neurotechnology in the military?
Yes, generally yes, and with some specifics as well. I mean, so I can speak to my knowledge of the way neuroscience and neurotechnology is being utilized in the military within the United States and within United States allies. And I can also speak, I think, with some authority about how international peer competitors may also be utilizing the neural and cognitive sciences. For most of the 20th century, there's been an increasing interest about how we might be able to access the brain and its functions in ways that might be augmentative in military agenda? In other words, could we improve the performance of our own people and modify the performance and capabilities of what may be a competitor or an adversary? And if you think back on the 20th century, things like nerve gas, things like specific weaponology, things like utilizing forms of methamphetamine, for example, the German army and all of its armed forces used a particular form of methamphetamine called pervitin. Consideration of how we might be able to use psychedelic drugs to modify individuals' perception, utilizing various forms of mind control, for example, in the United States, forms of neurocognitive, quote, brainwashing. So we see this long-standing interest. The problem has been that the science and technology had been rudimentary, both in our understanding of the brain and its complexities, and the actual capability of what we could then create. That was pretty much delimited as we got to the end of the 1960s and 1970s. So throughout the 60s and 70s, you're seeing an increased consideration and interest in utilizing the neuroscientific and neurocognitive tools to either optimize the capabilities of your own military intelligence forces, or to modify or decrement the capabilities of opposing forces. By the time we got into 1990s, that became a very, very real agenda. And certainly as we moved into the 2000s, these were just not a consideration, but it was actually a concept in practice. So we recognize now that there are discrete programs, both in the United States and NATO, that are very much devoted to understanding how the neurosciences can, will, and are being employed in military operations on a variety of battlescapes. And I have before you here, I don't know if you can see that, this is the most current NATO report on cognitive warfare that approaches the use of science, neuroscience, and technology in international agendas of military and intelligence orientations. And we have a similar one. It was just released by the US Pentagon, I'm holding it up for you here, which talks about emerging neuroscience and technology, near-term risks and threats to US and global biosecurity. So what we're seeing is that a number of nations actually have dedicated programs to evaluating how neuroscience can be used, will be used, and has been used in various initiatives and programs of national security, intelligence, and defense. Now, some of these are regulated by the current biological toxins and chemical weapons conventions and declarations of Helsinki. But only recently, within the past through review committees, has there been any discussion at all of the use of neurotechnology. And realistically, to this point, there's been almost no discussion of the viable weaponization of big data. So again, one of the things that our group has called for in our international discussions has been a review and revision of certain international treaties that examine how the brain sciences might be utilized or not utilized or should not be utilized in various international military agenda. Okay, so I hope I answered your question. Next question says, let me just jump into this. As you may already know, a while ago, France has been given the green light to develop augmented soldiers with the means of improving mental resilience and making them immune to stress. Do you think this is a harmless idea? No, I don't think that's a harmless idea at all. I mean, I think there are a number of things that arise from that. I mean, certainly we've had the go-ahead to do that in the United States for a while. There have also been other countries within NATO and within international alliances and international competitors that have viewed the neurosciences and cognitive sciences as a way of augmenting troops, whether they're military troops or intelligence personnel. That's an ongoing effort. So I think that there are a number of potential, let's call them burdens and risks, but not necessarily harms per se. What are the burdens? Well, the burdens are, do we really know what we're doing? Burden number one. Burden number two, how augmented should we make them? And who gets the augmentations? Number three, if these augmentations are creating, quote, super soldiers, are we going to see some form of brinksmanship? In other words, like an arms race towards augmentation that may be limited only by various cultures or nations' ethical parameters. Number four, what do we do with these augmented individuals when they're no longer in the military? Do we de-augment them? Or do we, in fact, cubbyhole them? Do we limit to the types of things that they can do because they now have these abilities? And if we do de-augment them, if these augmentations are no longer available to them, or if the augmentations become obsolete, how will we treat these individuals? Our group has actually developed a terminology called post-enablement distress syndrome, PEDS. How will we treat that? How will we treat former members of the military and intelligence services who've received these augmentations, but for whom the augmentations are no longer viable or they can no longer get them? Do we treat this as a disease, as a condition? Will we take care of those people? So we can see a number of benefits clearly in that we're providing these individuals operational protection and capability, and we're hoping keeping them out of harm's way, making them more effective in what it is that they do and therefore less vulnerable. But the burdens and the risks, they are potent. I hope I answered your question. Is there much of a discussion within the neuroscience community about things like patents? Will the use of neurotechnology be restricted because of capitalist interests? Wow, it's a great question. There is an entire field, an entire domain called the neurobioeconomy. And what we see is that neuroscience and technology has developed a tremendous multinational global economic market. And as I mentioned before, much of that market is being dictated and directed by developed countries that then have particular interest over developing or non-developed countries. As well, differing capabilities with regard to ethical precepts, constraints and restrictions about what can be done and what can't be done with regard to research and use and practice has also created relative asymmetries in the way certain countries are developing their brain science and neurocognitive sciences and capabilities. As well, what we're seeing is that international property and intellectual international property laws differ and may protect certain interests and may protect certain trajectories for product, service, and resource development that can then be leveraged to create dependencies on the global stage. Well, this is what, again, the French philosopher Michel Foucault has referred to as biopower. And when leveraged on large-scale international, cultural, and national capabilities, is referred to as biopolitics. And we've written extensively about the effect of the brain sciences on being leveraged in biopowerful and biopolitical ways, and it's something we're really concerned about. I believe I provided you with a reference to our most recent 2020 paper about the neurobioeconomy that deals with virtually all of these issues. And so if you're interested, please refer to that paper, or if you don't have that reference, just shoot me an email and I'll be happy to provide it to you. It provides an overview of the current neurobioeconomy and some of these exact issues with regard to capitalist versus non-capitalist versus egalitarian prospects and what that could mean for the developing economic marketplace. Next question, could we ever reach a balance between ensuring protection from harm and access to emerging neuroimaging technologies for minimally conscious patients? Very interesting. My colleague, Dr. Joseph Finns, has written a great book that I recommend to you. It's called Rights Come to Mind. And it approaches this exact issue, how we're using neuroassessment techniques and technologies, inclusive of various forms of neuroimaging and biomarkers, to be able to evaluate and define individuals' consciousness if and when those individuals have some impaired communication, minimally conscious states, vegetative states, locked in states, even coma. And also to be able to determine if that consciousness is accessible and how we may be able to access that consciousness. The other issue is, can we assess subjective states, sensory, perceptual, and emotive states of individuals who have communicative impairment, who are minimally conscious, vegetative, locked in? And what will we do with that? So right now, there is quite an effort involved as trying to create, if you will, what we call neurocognitive rights for the consciously impaired. One of the things that I've been working on with one of my colleagues from the European Union Human Brain Project, a woman whose name is Professor Katinka Evers, is that there should be large-scale international programs to develop these neurotechnologies in ethically sound ways to be able to do exactly this, to treat those patients that are very difficult to treat because we're not aware whether they are conscious or not, and that simple means of brain scanning may not necessarily reveal the fact that their consciousness has been preserved or has been revised in certain ways, but that there's still something there. And then what does that then mean for the way we regard and treat such patients? So a very, very good question. Any other questions? I'll take that as a resounding no. Well, I hope that you found this presentation to be at least interesting, if not informative. And my hope is that you also found it to be somewhat enjoyable and not terribly boring. I have a very thick New York accent. I was born and raised in New York City, so I hope you're able to understand my English. And again, my hope is that also that I continue to interact with your group. I'm very impressed with what it is you're doing, and I'd love to help. So feel free to call upon me as a resource for some forms of mentorship, guidance, interaction, and I'd be privileged and pleased to help you. And again, thank you very much for your interest in my work. Wait, there are more questions. The topic of military neuroscience. You said there was research on the uses of neuroscience as a means not to augment personnel, but towards adversary. Can I talk more a little bit about that? Oh, yes, absolutely, I can. There's actually a field called neuroweaponology. In other words, developing neuroscience as weapons. And there are a number of different domains that we can use. Basically, the ones that we're considered about are drugs, bugs, which are microbes and viruses, toxins, devices, and data. So this is what we call the fighting five: drugs, bugs, toxins, devices, and data. And there are international programs that are dedicated to examining how various drugs that work on the brain and nervous system, various microbes, viruses that work on the brain and nervous system, various organic and inorganic toxins that have a neurological effect, many of the devices we just spoke about, and also how data can be used in weaponizable ways to contend against others and influence, either directly or indirectly, their desire, their capability to be able to engage warfare or aggression, or in some cases, to threaten their viability. Now, one interesting point arises. Many of these approaches are viewed as sublethal. In other words, they're not oriented towards killing someone or even destroying things, but rather disrupting things. So they're viewed as instruments of effective disruption, right? Instruments of effective or instruments of precise disruption, IPDs, right? Which is very different than a weapon of mass destruction. But here too, there are a host of ethical issues. In other words, if I take someone who is my enemy and through some form of drug, toxin, device, whatever, I change that person's thought pattern and I now make them my friend, well, obviously we're not going to fight. But is that ethical? One could argue that's far less harmful than injuring them or killing them. But have I changed their self? And in so doing, is that a profound level of effect that has even deeper implications, particularly if that effect is subtle, clandestine, covert? And then what does that mean? On what level do we do that? When in Rome, not only do as the Romans do, but become a Roman, and we can make you have a Roman brain, so to speak? Do we engage these things on the battlefield so the battlefield isn't a battlefield anymore, but simply becomes a boardroom? And is that possible? Are there ways to ensure that any burdens, risks, and harms conferred by the use of neuroscience as weapons in these regards must be less than those of other conventional weapons that are used in similar or equivalent situations? And these are all considerations. If you're interested, hang on just a minute, just a moment. I'm just going to go to my library for a second. If this is something that you're interested in, and this is not a self-promotional plug, it's just information for you, may I refer you to this book. This is Neurotechnology and National Security and Defense, Practical Considerations and Neuroethical Concerns, an International Approach. The book is a little bit dated. It came out in 2015, and we're working on the second edition. It's available on Amazon. And it approaches many of the exact topics, interest, foci, and subjects that you've just raised in this and the prior question. It deals with how neuroscience and technology is being used in these multinational initiatives of national security, defense, and military. It deals with optimizing one's own people. It deals with using the neurosciences in things like interrogation and influence. And it addresses the ways that the neuroscience is being developed and used as possible weapons internationally, and what type of ethical issues arise from that what the ethical addresses need to be, what ethical and legal and social limitations are in place that may need to be addressed by groups such as yours. So I recommend it to you highly. The field is often talked about in conspiracies and urban legends because the concept of neuroweapon or violation of mind is frightening. Project MKUltra is infamous for that. Oh yeah, MKUltra is a real project, and not just the only project. I mean, there are certainly a number of others. And you must understand that the MK in MKUltra was actually a play on words because, as you may be aware, there were some ongoing research projects that were done during World War II Germany, during the Hitler regime in Germany, that were oriented towards different forms of mind control. So the idea of mind control, that's what the MK stands for, mind control ultra, where the K is sort of an allusion to the fact that the German word for control is Kontrolle. So yeah, I mean, MKUltra is infamous in that regard, the use of psychedelic agents, the use of electronic stimulation, et cetera, but it's not the only one. Realistically, there have been a number of other projects that have examined the use of neuroscientific tools and methods to be able to influence cognition, emotion, and behavior, both of one's own troops, so as to maximize their capabilities in doing what it is they do, as well as being able to decrement or modify the thoughts, emotions, and behaviors of opposing forces. So yeah, and yeah, there's a lot of misinformation out there. For example, I mean, one of the things that is getting a lot of popular media press right now is something called the Havana Syndrome, which involves the use of a directed energy weapon against particular personnel at the US Embassy in Havana. It's actually something I've worked on for a number of years. And there's a lot of misinformation and miscommunication out there. And remember, one of the important things in any approach to the brain sciences with regard to neuroethics and risk reduction is a realistic assessment and realistic description of what the science and technology can't do and what it can do. So understanding those realistic capabilities and limitations is the first step towards developing factual analysis that is so important to any ethical approach and address. So you make a good point. Okay. Any other questions?
I think we've covered all the questions so far.
Very good. Well, if you have any others, if any other pop up, and sometimes you have to think about this a little bit, please feel free to write me through your Medgeía website, or write me at my email. Again, you have my email, james.giordano@georgetown.edu, and I'll be happy to address your questions. Again, send it to me from your Medgeía website. I'll know that it has to do a lot about this. Where can you learn more about some of the work on Havana syndrome? Interesting. There are a couple of articles that have come out in the general media that have been very, very well done. Probably the best one around is one that appears in the magazine, The New Yorker. It's an American magazine. There was also a very, very good article in the Danish press. And recently there was a great article in the German press. The Danish one is written in Danish. And the German one is written in German. And I had the pleasure, ich bin ein deutscher Sprecher auch. I'm a German speaker as well. And so I had the privilege of actually being interviewed for that article. But if you'd like, once again, just send me an email and I'll be happy to send you the links, or perhaps I can even send you PDFs of those articles. And you can learn a little bit more about the Havana syndrome. It's a work in progress. We haven't exactly figured it out. But it seems to be that the actual case there is that some form of a directed energy device was utilized as a weapon to disrupt and severely alter the cognitions, behaviors, and health of some key personnel at the US Embassy in Havana. And there have been other such incidences since. The original set of affected individuals was about 26, but since 2017, we've amassed a case file of about 130 individuals who seem to have been affected by such things all over the world. So it's interesting, and it's a bit frightening. Great. Indeed, it is. Okay. So if you have no further questions for me. Going once. Going twice. Sarah, I hand it over to you.
Well, I think all of the questions have been answered. I was just going through the questions in the chat.
Mhm.
And therefore, I think we can conclude this wonderful session.
Thank you very, very much. It was a pleasure. And again, thank you so much for your interest in my work.
Recording stopped.
Have a good day, all.
You too. Thank you very much. And we'll be posting the recording in the Discord Medgeía channel.